Well, I'm kind of glad we've moved out of limits, and now we're going to kind of apply the that limit concept, and we're going to move on to what's called the derivative. And we're going to first start with the definition of the derivative, which a lot of you aren't going to like, but we got to at least build the derivative, and we're going to do that by using the limit. And I got a nice picture here to look at. Okay, so this green line here is the graph of our function, and we got a bunch of straight lines here, and I'll explain that. Obviously, well, we got two important points here on the graph, and that's x and f of x. So, and I've kind of centered that at the origin, but more generally it's x, f of x. And then we've got this other special point up here, and it's x plus delta x, f of x plus delta x. And what I mean by this delta x thing here is that if my x is here and delta x is some number, we're going to add 2x. So x plus some number, and that and that number is delta x. And delta really means difference in x, but just think of it as we're here at x, and then we're going to add some number to it, so it looks like maybe I don't know what that is, 4.5 or something, if that's 4. So if x were 0, I should say, and we're adding delta x would be like 4.5. So this whole thing right here, since this would be 0 plus 4.5, the whole thing would just be 4.5. Okay. So we're coming out some delta x, and I go straight up, right? So that's my y value, f of x plus delta x, and this is my new x value here, x plus delta x. All right. I'm going to draw a line that passes through and this looks like the origin here, so we'll just say it's the origin. But I'm drawing a line that passes through the origin, and then this point right here, x plus delta x, comma, f of x plus delta x, alright? Okay, and you notice the slope of the line, alright? Take a note of the slope of the line. Now, if I take this point and I move it down, and now here's our new line. And by the way, this line is known as the secant line. The secant line is passing through 2 points on our graph here, and we call this line the secant line. But if I take this point and I move it down, as I move it down, okay, so here's a snapshot in time, and if you've noticed that our slope is decreasing, right? So let's say the slope here is, I don't know, it's a little more than 1, and we'll say the slope of this line here is a little less than 1. And then you keep moving it down. Now, as I move this point down, what's actually happening to delta x? Well, delta x is what? Delta x is decreasing, right? Delta x is decreasing. And you notice that the slope in our line is also decreasing. So we keep moving it along, and our secant line, as you can see here, the slope of the secant line is also decreasing. Okay. Now, what happens when delta x starts getting closer and closer to 0, right? Delta x is getting smaller and smaller and smaller. Well, what's happening here is the secant line, as you can see, the slope of the secant line is, well, in this particular case, it's what? As delta x gets closer and closer to 0, the secant line, right, gets closer and closer to, the slope of the secant line gets closer and closer to 0. Alright, so we say as delta x approaches 0, our secant line is approaching what is known as our tangent line. And this red line right here is considered to be our tangent line. Now, what I'm going to do here is I'm going to find the slope of the secant line. I want to find the slope of the secant line. So it's just like finding the slope, right, of line that passes through 2 points on the graph. It's y2 minus y1 over x2 minus x1, and that's what we're going to do. So this right here is like our y2 minus our y1, and this is, if this were x2 minus x of 1, what would end up happening is it would all cancel out, and you would just get delta x in the bottom. I should have probably written this out. Well, we're talking about finding the slope of the secant line, and what I did was I went ahead and plugged in x plus delta x down here in the bottom to kind of show you what's happening here. Remember, this was y2 minus y1 over x of 2 minus x of 1. So that's what you might be more familiar with finding the slope of the line when you're given 2 points. But anyway, what happens here is x plus delta x minus x. As you can see here, the x's cancel out, and so we're just left with delta x. So this is the formula right here that we're going to use to find the slope of the secant line, and m is usually known as the slope, and I've got a subscript here as secant. But what we're going to really want to do is find the slope of the tangent line, but we're going to first use this and then introduce the limit. Okay, so we want to find this time the slope of the tangent line, and it's equal to this notation here, f prime of x, little prime sign right there, call it prime. I remember when I first seen that, I was like, what the heck is that? Is that a 1? But it's just a little prime. We call that a prime. Okay, it's equal to the limit as delta x approaches 0. Now remember, back up in that graph I was telling you, remember, as delta x gets smaller and smaller and smaller, right, the secant line approaches the tangent line. And so remember, this was the formula for finding the slope of the secant line, but now we're going to use this idea of the limit to actually find the slope of the tangent line. And here's some examples down here. Okay, so I've got some examples of what a tangent line is. Now, this line right here, I'd say it's purple, but it may not be purple on YouTube or whatever. But this line here is passing through this point and this point on the graph. So this line is a secant line. Okay, this is the secant line. But let's say this line right here, this is known as the tangent line. Now you notice it's kind of touching here at just one point on the graph. So that is a tangent line. This line right here is also called the tangent line, right, at this particular point. Now this is kind of a special one here. Notice that this line right here, this tangent line here, it has a slope of, well, it should be 0. Okay, it's totally horizontal. So it has a slope of 0, and that kind of tells you where the maximum point is, right? The highest point on this curve right here. And that's something that we're going to talk about later. And so anyway, so this has got a positive slope, this line here. Now here's another tangent line, and it has negative slope. And remember, we read our graphs from left to right, So if I'm reading the graph from left to right, you can see this has positive slope. That means that the graph right here is increasing. And because this slope here is negative, right, that means at this point here that the graph is decreasing. Remember, we are reading these graphs from left to right. So at this point here it's decreasing, and then tangent line here would be 0, and then tangent line, let's say right here, would be positive, so it'd be increasing, and so forth. And all these things that I'm saying is things we're going to be talking about over and over again later.